Cloud computing and fog computing, key differences and advantages. Cloud computing and fog computing are two well-known concepts that have become effective methods for managing, processing, and storing data in the world of computer technology. The way companies and people manage their digital operations has been revolutionized by these creative strategies. Despite having similar goals, they differ greatly in terms of design, deployment strategies, and advantages they offer. Understanding the main distinctions between cloud computing and fog computing, as well as their unique traits, advantages, and ramifications, is crucial for navigating this technological environment. The nuances of these two paradigms will be discussed in this essay, along with each one's unique strengths and ideal applications. By the end, readers will have a solid understanding of both cloud computing and fog computing, enabling them to select the approach that most closely matches their requirements and goals.
But before we start moving forward, make sure to subscribe channel and click on the bell icon. Sprintzeal provides training programs, certification programs on their websites. If you're interested in them, do check out the links in the description.
Key differences. Cloud computing. It entails the internet-based distribution of computer resources such servers, storage, databases, networking, and applications. It is dependent on centralized data centers in far-off places, sometimes known as the cloud. Users may use these resources whenever they choose, just paying for the services they really use. Scalability, flexibility, and cost-effectiveness of cloud computing make it perfect for processing and storing enormous amounts of data. Fog computing. Edge computing, as it is commonly referred as, adopts a decentralized strategy by bringing computer resources closer to the data source. Fog computing expands the capabilities of the cloud to the network edge, such as routers, gateways, and edge devices, as opposed to exclusively depending on distant data centers. Localized decision-making is made possible by the closeness to data sources, which also improves real-time data processing and lowers latency. When low latency, high bandwidth, and offline capabilities are required, fog computing is very useful. Differences in detail. Although data storage, processing, and administration are the same goals of both cloud computing and fog computing, they differ greatly in terms of design, latency, and bandwidth, as well as data privacy and security. Understanding these variations is essential for navigating the technology environment and selecting the strategy that best suits a given set of requirements and objectives. The nuances of cloud computing and fog computing will be thoroughly discussed in this section, along with their distinctive features and distinguishing qualities. Readers will obtain a thorough grasp of how these paradigms vary and the situations in which they thrive by looking into the architecture, latency and bandwidth issues, and data privacy and security implications of each paradigm. Architecture. Cloud computing adopts a hierarchical architecture with a centralized model. It employs a network of remote data centers where data processing, storage, and management occur. Users access these resources through the Internet, typically utilizing virtualized environments. Fog computing, on the other hand, follows a distributed architecture. It decentralizes data processing by bringing computing resources closer to the network edge. This distributed model allows for faster data analysis, reduced bandwidth usage, and enhanced privacy. Latency and bandwidth. Cloud computing solutions often involve data transmission to remote servers, which introduces latency due to the distance and network congestion. While cloud systems provide ample bandwidth, real-time applications that require immediate response times may suffer from noticeable delays. Fog computing resolves this issue by enabling local data processing at the network edge, significantly reducing latency and optimizing bandwidth usage. This capability is crucial for time-sensitive applications like autonomous vehicles, industrial automation, and Internet of Things, IoT, deployments. Data privacy and security. With cloud computing, data is stored and processed in remote data centers managed by cloud service providers. While these providers adhere to stringent security measures, concerns regarding data privacy and compliance regulations persist. Fog computing addresses these concerns by keeping sensitive data closer to its source, reducing the need for extensive data transfers and reliance on external data centers. This localized approach enhances privacy, minimizes exposure to potential security breaches, and allows for greater control over data governance. Benefits. Cloud computing and fog computing offer distinct sets of benefits that cater to different needs and requirements in the realm of computing technologies. Organizations and people must be aware of these benefits in order to choose the paradigm that is best suited for their unique use cases. We will examine the advantages of both cloud computing and fog computing in this section. we will look at the benefits of scalability, affordability, and accessibility for cloud computing. On the other hand, we will delve into the benefits of fog computing, such as low latency, bandwidth optimization, and offline capabilities. By understanding these advantages, readers will be able to assess the potential impact of each paradigm on their operations and determine the most appropriate approach to fulfill their computing needs. Cloud computing benefits. Scalability. Cloud computing offers virtually unlimited scalability, allowing businesses to easily upscale or downscale their resources based on demand. Cost efficiency. Users pay only for the resources they use, eliminating the need for upfront infrastructure investments and reducing operational costs. Accessibility. Cloud services are accessible from anywhere with an internet connection, enabling remote collaboration and flexibility. Fog computing benefits. Low latency. By processing data closer to the edge, fog computing significantly reduces response times, enabling real-time applications and enhancing user experiences. Bandwidth optimization. Localized data processing minimizes the need for large data transfers, optimizing bandwidth usage and reducing network congestion. Offline capabilities. Fog computing enables offline functionality, ensuring uninterrupted operations in scenarios where internet connectivity is limited or unreliable.
If you found this video informative and useful, we'll always bring new concepts explained for you, so stay tuned with Sprintzeal, and if you like the video, do share. If have any doubts or queries, do let us know in the comment section. Use the coupon code YouTube10 in our website to get 10% off on all our courses.